this video, I'm going to be going over a sample problem that will teach us how to solve atomic mass problems that involve systems of equations or require us to use systems of equations to solve them. So these aren't our traditional average atomic mass problems where we're actually given data on an element and needing to solve for the average atomic mass. They're problems that involve data with elements and maybe require us to look up the average atomic mass and use that data to solve for some other aspects that are related to the atomic mass of an element. So let's see what I'm talking about. Let's read the problem. So here it tells us that the primary naturally occurring isotope of magnesium makes up 78.99% of all magnesium atoms, and it tells us its mass, which is 23.98504 atomic mass units. The other two naturally occurring isotopes have masses of 24.98584 AMUs and 25.9829 AMUs. What are the percent abundance of each of the other isotopes? So, we're given a lot of data on magnesium and its isotopes, including all the masses of the isotopes, but only one of the percent abundances of the major isotope. The other isotopes, we actually have to solve for the percent abundances. So that's why this problem is different. So like any word problem that might seem a little crazy, we always want to take our 3 steps of problem solving. The first being to understand the problem. And that, in other words, is write down what we already know, okay? And help us organize our thoughts. And when it comes to average atomic mass type problems, we always want to do that kind of chart, because that chart is like our plan. It's our game plan. It's how we almost always solve these types of problems in one form or another. So I always want to make a column for my mass, a column for my percent abundance, and then a column for my decimal percent, because we always do the math with the decimal percents. Okay, so we're told that the first mass is 23.98504. Then we have the other isotopes, which are 24.98584. And then 25.9829. Okay. Now, we only have 1% abundance for the major isotope, which was the 23.98504, and that is 78.99. Okay. Great. So we've written out everything that it actually tells us. Now, the other thing is to write out stuff that we might need that we don't know. That's step 2, right? And since it's an element on the periodic table and we can get its average atomic mass, you can almost always bet that we're going to need that. So I got a little periodic table here I'm just going to blow up. I didn't have you guys should always use the one that I gave you online, so use that one, but I didn't have a copy on my iPad, so I'm going to use this one. It'll work for my example. So magnesium's average atomic mass is 24.30. Not a lot of sig figs, so it's not good for your purposes, but so you guys want to use the one I gave you. But 24.30. Okay, so I can ditch this for now. All right, third step is to make a plan and carry it out. And the nice thing about organizing our data into a chart is we're kind of already making a plan by using our chart. Make/carry out plan. And so I'm going to kind of just draw an arrow up here because that's kind of what we're already doing. We're just going to continue to do it now. All right, so one of the things that we always want to do is use the table how we normally would use it as much as we can. In other words, let's turn our percents into decimals, because that's the first step in using this chart, right? So we have 1%. Let's turn it into a decimal. We move our decimal over to the left 2 places because we're dividing by 100. And that turns this into 0.7899. And what would we normally do with that? Well, remember, we would normally kind of ignore this, and we would multiply the decimal by the mass, the decimal percent by the mass, and we would get a number. So let's do it. Let's carry out what we normally would carry out. So that's 23.98504 times 0.7899. And that's going to be the 4 significant digits because that's the least amount between the 2 numbers that we're multiplying. And that gives us 18.945783096. And I said 4 sig figs, right? All right, cool. So we got a number. Normally, and we can't really do anything else with percents and stuff because we don't have them, but we would add up whatever numbers we get, and that would give us our average atomic mass, which we already know is 24.30. Okay? So what we would normally do is we would get these numbers. Now we know we want these. This is kind of like our goal, is to solve for x and y and then turn them into the percentages, which is what our answer is going to be. We'll call that, I don't know, z and w. Why not? Okay? Because our math is going to solve us for x and y, and then we can just easily turn those into z and w, right? And there's a little more math, but we can do though, right? We can solve for whatever this part's going to be, can't we? Like together, right? Because all you have to do is subtract 24 or subtract 18.94 from 24.30, right? So let's do that. So set that up vertically. So that's going to be 24.30 minus 18.945783096. And what we're doing here is, again, we're making our plan using the plan we already know to kind of get it down as simple as possible to see how we can solve this. All right, 24.30 minus 18.945783096, and that's going to be to here. So I get 5.354216904, and that's going to equal this box over here. Okay, so we've got this as simple as we can really get it for now. So now here's where comes the new part where we have to use what's called a systems of equations. This is an algebra skill you probably learned it, maybe some of you a while ago, maybe some of you more recently. And we have to kind of think algebraically now. So what we want to understand is this. Okay, when we have a percents add up to equal 100, right? That means that all these percents together added up will equal 100. So we could say, okay, z plus w plus 78.99 equals 100%, right? That makes sense. Okay, well, that's cool, but the math that we're really doing deals with the decimal percent. So this is really the variables that I'm going to be using, x and y. Well, if you're moving the decimal point over to get your decimal 2 places to the left, for these, right? What that's going to do here is the same thing for your 100. So I can use the same equation idea for my x and my y. I can say x plus y plus 0.788 equals 1, right? So let's just forget this, since the x and the y is what I'm going to be using. And now I can have a new equation, okay? So let's say x plus y equals 1 minus 0.788, right? Because I can subtract 0.788 away from both sides. And that will simplify this equation, all right? So what's 1 minus 0.788? That's 0.212. So x plus y equals 0.212. Cool, that's one equation. That's an algebraic equation I can use. Are there any other algebraic equations I can use? Well, there actually are, and this one's a little harder to see, but once you see it, you see it. All right, so we know that we're not really using z and w in solving the problem yet. They're just kind of what our end goal. What we are using is, I'm going to make this, is this, right? We're multiplying, that's a multiplication x, not a variable x. We're multiplying this number times x to get what's in here. We're multiplying this number times y to get what's in here. Then we're adding those up to get this number. Let's make an equation out of that, right? Let's follow through with that. 24.98584x. That goes in there. 25.9829y, right? And we already solved that these two added up, the sum of these equals this. That's an equation. Let's write it out. 24.98584x plus 25.9829y equals 5.354216904366. Man, we got two equations, both with x and y in them, that we can now use to solve for x and y, which will get us to z and w, right? Okay, so let's do it. This is where we use what's called the systems of equations. Well, when we have an equation, we really only want one variable in an equation to be able to solve for it, right? This is where we use the systems equations to do that. We can simplify one of our equations and make it equal to one variable. And you only want to pick one of the equations to do that with. But you want to pick the easiest one to make it equal to one variable. It'd be a lot harder to try to get x by itself or y by itself in this equation. It's really easy to do that in this equation. So let's get x or y by itself in this equation. I like to make x by itself, because I like x. So in order to do that, I'm going to subtract both sides by y. Right? If I do that, I get x equals 0.212 minus y. Now, because I did that, what I can now do is I can substitute in this, since it equals x, into this equation, where there's the x. And now this whole equation over here on the right will only have y in it. So I have to rewrite it. Times 0.212 minus y, right? Okay. Now that I only have y in there, I can simplify this equation down until y is by itself, and I've solved for y. And this is the more tedious part, okay? So the first step in doing that is to distribute in this. And I have to keep track of my sig figs throughout. So the first thing I want to do is multiply 24.9854 times 5.212, and that's going to have 3 sig figs in the answer, right? And that's going to get me 5.2969,048 with 3 sig figs. And then I'm going to have that minus 24.9854y. That's then added to 25.9829y equal to 5.354216904. Now that I have that, I can subtract away 5.2969,048 from both sides. All right? So I'm going to do that. 5.296,904. Oops, doing the wrong math. 5.35421,6904 minus 5.296,904.8. All right, and I get 0.057312,104, and that will have one significant digit in it. All right, now I've got on the left negative 24.9854y plus 25.9829y. And what I need to do, whoops, let me redo that. Make that a little more consolidated. Equals. Okay, now I need to distribute out my y to get everything simplified. If I distribute out my y, oops, I'll get y 24.9854 plus 25.9829. That will go down here, and I'll get 0.057312,104 equal to y times, let's do the math and find out what it is, negative 24.9854 plus 25.9829, and that is 0.9975. I divide both sides by 0.9975, and I will finally get what y is equal to. Zero 0.0573 2104, and this will have one sig fig in it. So I get 0.05 0.0557.5. Okay. Oops. All right, so that's one sig fig. Now I'm going to keep that at one sig fig for now. So if I zoom back into my big picture here, I can see that y all the way up here is 0.0575, and that's with one sig fig in it, okay? But we need x, right? We need x. Oops, I pointed that to the wrong one. Let's go back. It's y, not x. Y. Okay, I need x still. So if I plug in my y into this equation here, I can solve for x, can't I? Actually, easier to plug it back into this equation here, right? So if I plug it into the y there, I can easily solve for x. So all I have to do, let's do it in green, make it easier to see. I simply do 0.212 minus 0.0575, that's 1 sig fig, and I will get my x. And x equals 0.1545 to 1 sig fig. Or see, that would be 2 sig figs actually, because if I do my math vertically, it will come to this decimal place. Okay, so I always recommend do these addition and subtraction steps vertically. I've done this a while, so I can do it quick in my head. But all right, so we have x, we have y. Now we want to convert them into z and w, which just means move your decimal place to the right 2 times to turn them back into percents, right? So if we turn this into a percent, we go to the right once, to the right twice, and we get we get 5.75, but it's 1 sig fig, so it ends up being 6%, okay? So x equals 6% abundance, y equals 2 spaces, 1, 2, this ends up being 15% abundance. And you can check yourself by adding these all up, right? So 15 plus 6 plus 78.99 should be roughly 100%. So let's do that. 6 plus 15 plus 78.99, I got 99.99, which is, I would say, roughly 100. So good job. That's how we do it. Now, obviously, this is tedious work. It's a lot of steps, but it really, why do I give these problems as some of the first, challenge problems? Because they are some of the hardest ones you'll ever do in this class. Because they really test your ability to think in a stepwise fashion, test your sig fig math, okay, and make sure that you know how to work through processes in a stepwise fashion. Because really the rest of the problems in this class, you have to think in a stepwise process, okay? And not give up, break things down into steps. All right, so this is how you're going to solve the challenge problem on your homework, the one that involves chlorine. You want to use the same exact process that I showed. Okay.